I don't know if you've been in a really bad relationship or a really bad workplace where that environment is not conducive to you feeling good, okay? And so it's really hard to be in full health when that is happening. So, but when you start to hang around with a bunch of legendary people like yourselves, okay, that are into building a healthy community, you generally start to feel fantastic, okay, because you're actually turning on the right genes. It's your social interactions that are starting to upregulate how you're feeling. We've also got indoors and outdoors, so indoor spaces and outdoor places are really going to have an impact on our genetic expression. So some people like it nice and ordered and particular in their environment, and other people like organised mess, yeah? But it will actually have a really significant impact on how our genes express. And that's also down to our outdoors. You know, some people love really wide, expansive places. Some people like it really hot. Some people like it when it's nice and cool. So we know that that's actually going to be interplaying with our genes and giving us the results that we get. We've also got exercise. You all know very, very well how that interplays with our genes. We've got career. So career is a big one, and Kyle touched on that this morning, that you know, we can be in a really amazing environment. If we're working in our genius zone, if we're in our flow, we are going to have a more significant healthy response in our body. Okay, whereas if we're stuck in somewhere where we really hate and we really don't like, it's going to have a detrimental effect on our body. Sleep. Who here has been well slept last night? Awesome. Some of us don't get so much sleep. I'm a mother of two. I sometimes get interrupted. So we all know how that plays
quite
out the
often.
next day, right? We're not so sweet and loving with our loved ones. And the mind. So the neurochemistry, we know a lot about. We're starting to learn and get more information around the sciences of how we're thinking will determine how we're feeling and how our genes will actually start to express. So a lot of that work comes from Bruce Lipton and Greg Braden and all those guys. So it's a really, really interesting area to look at. But all of these things essentially are going to be, you've got the protein strands, the genes, they're all codes, and then these things here are actually going to start to put some pressure on those proteins and then you're actually going to start to express, and there we have our result of that, a result of our gene expression. So we're going to dive a little bit more into what is a phenotype, just so we get it really, really clear. That's any function or form of the body is part of your phenotype, okay? So all of these things here on the screen are phenotypes, okay? So a headache is a phenotype. A stomachache is a phenotype, okay? We've got a brain tumour is actually a phenotype. We've got our blood pressure and our cholesterol. And here with our musculature, with our muscle growth, if you put a body in a gym and they start picking up weights, the genes are realizing that they're the body is in a heavy environment, okay? So it says, boy, we've got heaviness going on here. We need to adapt. We need to get stronger. So it's actually going to start the expression of pumping out more growth hormone so that those muscles get bigger, okay? And it's adapting to the environment that it's in. Does that make sense to everyone?
That's what I have for breakfast.
Can I just ask about
Yes.
the brain tumour?
Yes.
I mean, everything else seems fairly, almost kind of like your vitals, do you know what I mean? Like your
Yes.
cholesterol and blood, but the brain tumour's a little bit heavier than that. How is that based as a phenotype compared to the others?
It's what the body
Good
is
question.
actually being told what to do. So the genes are actually up and down regulating. They're being turned on and off depending on what environment it's bathed in. So it could be toxins, okay? It could be, what we're saying here is it's not just genetic, Okay, something has to turn that gene on or off for that tumour to grow. Okay, so you know, when you have extra growth in the body, it just means there's a runaway situation going on for that body. Okay, we have natural killer cells in our body, and we have apoptosis, which is happening all the time. So we're all growing cancer cells every single day. It's just that we can actually turn them off. Okay, whereas what happens here is something's happened and they haven't been able to turn off. Okay, so it's what's determining that is the environment that it's bathed in. Does that make sense?
Yeah.
Great explanation.
But it's actually a physical expression of what the genes have been exposed to, so to speak.
So obviously, if that's secondary to breast cancer and then they've acquired brain cancer, is it because obviously it's originated from the breast?
Yeah, that's right. So it actually spreads to the body through the immune system. Okay, so when we get secondary stuff, it actually goes to, well, those cells start to travel, and they start to go to areas where our organs where we're trying to clear that, and so it'll actually start to grow there. So it obviously spreads around the body, and that's what they try to stop.
Yeah, it's just interesting how it was kind of just in.
Yeah, I know it is. It's interesting to think of it like this, because sometimes we don't actually understand that what we're doing when we see a person, we're actually looking at their phenotype. Okay, and when you're in exercise, when you're working with people doing exercise, or when you're in the daycare centre, you're actually looking and measuring phenotype. Okay, the physical expression of those genes. You actually can't see your genes. Okay, you can't measure those genes internally. We can, but they're not telling us what is being turned on and off. Okay, so when I became a clinician, the hot topic of the day was to actually look at gene measuring. But what I discovered and realised when I researched it and looked into it is that it actually isn't telling us what's turned on right now. There might be a SNP, there might be a coding there, but it doesn't necessarily mean that it's expressing at that moment. Okay, we'll dive a little bit more into that as we get along the way. So genotype alone isn't adequate, okay? And that's, as I mentioned before, the old paradigm, the Newtonian science, is that, you know, germs cause illness, genes cause disease, and we're moving away from that model now, where we understand that it's not just the genes. Okay, so would you give these two ladies here, would you give them the same health program? No. Okay, good. Pretty obvious, right? So they have the same genes, okay, so these are identical twins. As you can see, they've been bathed in different environments because we obviously have different phenotype expressions going on here. And without it, we don't know the starting point, all right? So if you just looked at the genes alone, you would probably roll out the same health program for both of these. If you didn't see the phenotype, okay, you would probably be thinking, all right, we're looking at these genes, and these genes would be good for this program, okay? However, it's the environment that has shaped the gene expression is what we need to treat, is what we need to look at, and what we need to measure. Okay, so this is where we actually get a starting point, and then we can go in and find out how we're progressing with our interventions. All right, so this is a really important part of understanding how this is playing out. So understanding epigenetics, so epi just means on or around the gene, okay? What is in it? So when we're actually in the womb, we are bathed in an environment, okay? So what is that environment, and what's turning things on or off? So what we also know around genes is that they have these switches, okay? So that's a nice little representation of what's going on here. So we have all these little DNA codes, and as the feedback comes in, it actually starts to get a message out of that, all right? And then that's when you actually have a snip and you have a switch and it turns it on, all right? Does everyone understand around gene? Yeah? Gene switches? Okay, so we've actually got our short-term switches. So if you're having a cup of coffee, I don't know who had coffee here this morning, essentially you've got about an 8-hour window of stimulation around your genes of alertness, of pumping out some hormones that are the noradrenaline and the dopamine. It's actually going to make you feel really alert and give you that rush feeling. We know that the caffeine sticks around in the body for about 24 hours, so it's a short-term switch, okay? Whereas we know that if we're measuring the hip-waist ratio, we know that if over a period of a few weeks that is expanded, we're getting a sense of the lifestyle that the person has chosen over the last 4 to 8 weeks, because we'll often see with an expansion more cortisol. Okay, so we actually start to understand that when we're doing that simple measure, it's telling us about the lifestyle choices and the genes that have interplayed with those choices to have the outcome of the hormonal increase in the body, resulting in a wider girth. The other switches that we have are a bit more longer term switches. Okay, so the bone is a really, really good measure. The skeletal system is an excellent measure of the influence, the hormonal influence that we've had over a longer period of time. Okay, so between 12 to sort of 18 years, as we're growing, we've been bathed in a cocktail of hormones that are influencing the growth of those bones. Okay, and sort of it starts to as we get to adulthood, that influence is not there anymore because we've actually capped our growth. So we generally stay fairly stable in our skeletal system. But we can actually look back at that and use it as a reference for how, what hormones were actually influencing that growth, right? So longer term. And then we also know even longer term switches are the things like, I don't know if anyone has worked with pregnant women, but we know that if they choose certain lifestyle choices while they're pregnant, it can actually have an impact for up to 3 generations. So a woman smoking in pregnancy can increase the asthma risk for the next 3 generations.
Whoa.
It's huge, right? So it's not to say that
So good.
if the child that has a smoking mother doesn't smoke, they can actually affect the gene switch, so they can actually keep it turned off. Okay, so it's through our lifestyle choices. We can have the setup, we can have the gene cluster, the variation of those genes together that are sitting there like a loaded gun, but we don't have to pull the trigger. Does that make sense? Mm-hmm. Yeah. So essentially we've got, just to recap, we've got short-term switches, we've got intermediate switches, and we've got long-term and generational switches. Okay, so what we'd like you to understand is what's gone into this platform, because it is